Hello guys, this is Mr. Holly. Today I'm going to be talking about solving equations that involve the distributive property. So in this case, we've got an equation that has a factor of 3 multiplied times the quantity of x plus 4. So we need to talk about what are our strategies for how we might solve a problem like this. And there's really 2 ways to go about it. So I'm going to show you both, and I'm going to show you several different examples. But the most common strategy here is that we would try to put the left side of our equation into standard form before we would attempt to solve. So I can actually manipulate this left side of the equation without changing the value, right? We would just be writing it as a different but equivalent expression. So 3 times the quantity of x plus 4, I could use the distributive property and rewrite that as 3x plus 12 is equal to 21. And at this point, I have not changed the value at all. Like, I have just rewritten this as a different but still equivalent expression using the distributive property. So now I've got a simple 2-step equation that you should be comfortable solving at this point. I'm going to subtract 12, and when I subtract 12 on the left side, I have to do an equivalent move on the right side to keep things equal. This makes my constant value 0, and now I have 3x is equal to 9. So if I have a coefficient of 3 and I would like to find what 1x is, I would need to divide by 3, and I would get that x is equal to 3. Now, like I said, there are other strategies. Another way that we could look at this same problem thinking about this problem, this is 3 groups of x plus 4 is equal to 21. 3 groups of the quantity x plus 4. Well, what would 1 group of x plus 4 be equal to? I think we could figure that out. We could look at this problem and say, well, instead of 3 groups of x plus 4 is equal to 21, I could go ahead and make an equivalent move on both sides of the equation here, divide by 3, and find that 1 group of x plus 4, or just x plus 4, is equal to 7. At that point, I would need to try to isolate x by getting rid of the constant of 4. I would subtract 4, do the same thing on the other side. X is equal to 3. As you can see, obviously we're going to get the same answer either way because there is only one value of x, one value for x that makes this equation true. There are just different strategies for how to solve it. I would say this is going to be the most common, but I would encourage you to try to do it both ways to see if you can make sense of it in both, using both strategies. So let's look at a couple more of these. I'm going to try to mix in as many things that misconceptions and obstacles, things that might cause you to stumble as you're attempting these problems. I'm going to try to mix as many of these in as I can. So here what we have is, instead of having a sum, we have a difference inside the parentheses. So there is some subtraction inside the parentheses. So now when I think about this distribution, really have to be mindful of the sign here before the 4. So let's go ahead and do that. 5 times 3x is 15x. And now I have 5 times, this is minus 4. I could think about that as plus negative 4, or I could just think about this quantity as this number and the sign before it. I'm subtracting 4. So 5 times negative 4, this would be minus 20. And this is really the big difference, is we've got to make sure that we get the sign correct. This constant value is a minus 20 or a negative 20, and we need to realize that that is a negative value. So now, in order to get back to 0 on our constant, I'm going to be adding 20 to both sides of the equation. 15x is equal to 25 plus 20 is 45. And then my next move that I would make here is to divide by 15 to isolate, just get 1x. And that's equal to 3. All right, let's move on to another example. Now in this example, we're going to add another layer of complexity by putting a negative coefficient on the outside of the parentheses. So as I look at this equation, I see negative 4 times the difference of x minus 3. So I'm going to still distribute. This is a negative times a positive, negative 4x. And then again, I have subtraction here. So negative 4 times minus 3, or negative 3, well, a negative times a negative, that becomes a positive value. It's positive 12. It's equal to 4. Now, I would also have to go ahead and subtract this 12 from both sides. Let's get negative 4x is equal to negative 8. And now I would need to, in order to get x by itself, have a negative coefficient. Remember, our goal is to create positive 1. In order to create a positive coefficient, I would have to divide the negative coefficient by a negative coefficient. So negative 4 divided by negative 4. Now I have a positive 1. And on this side, I'm dividing by negative 4 as well. And x is equal to 2. Okay. Let's go up just one more degree of complexity here. What if we have a coefficient that is a fraction? Okay, all of the rules that we learned about, that you know about multiplication, addition, about generating equivalent expressions, all of these rules and properties, they apply just the same to fractions as they do to any other number. Okay, so we're still going to do the same processes here. We are going to distribute. 3/4 times x is 3/4 x. And 3/4 times minus 12, or negative 12, is going to be a negative, or a minus 9. And you could come over and do that multiplication if you needed to. 3/4 times 12, that's 12 over 1, is 36 over 4, or 9, okay? And remember that that's negative, so this is, your answer is going to be negative. Okay, that's equal to 27. Now, my next step, I want to add 9 to both sides of the equation. This creates a 0 pair. And 3/4 x is equal to 27 plus 9 is 36. Now, I need to solve for this. So 3/4 of x is equal to 36. So now we get to this situation where, well, in the past, what I've done is I've divided by the coefficient. Well, now we need to use our understanding of multiplicative inverse, that dividing by 3/4, while that is accurate, it's easier to say that we would like to multiply by the reciprocal of 3/4. So multiplying by the reciprocal would be 4/3 times 3/4. The reciprocal being, if I take this fraction and I invert it, or take the inverse of it, I get 4/3. I'm going to do the same thing over here, multiply by 4/3. Now let's look and see here for just a second. Why are we multiplying by the reciprocal? Well, look what happens when I multiply any number times its inverse, or its reciprocal. 4 times 3 and 3 times 4, that's 12 over 12. And all I'm doing is creating 1, because my goal is to get x by itself. We want 1x. So anytime I would multiply something by its inverse or reciprocal, I'm obviously creating a fraction where the numerator and denominator are the same. So that's the strategy that we're using here with multiplicative inverse. On this right side, I need to go ahead and multiply so I can figure out my solution for x. What I would do is simplify this. 36 over 3 simplifies to 12 over 1, and 12 times 4 is 48. So 36 times 4/3, x is equal to 48. All right, I'm going to put in one more level of complexity here for you with distribution. there is a potential that you could get a problem where you have to distribute like 6 times 5x plus 3, the quantity of 5x plus 3, plus 2. Maybe you have an additional term there, and we've got to combine like terms before we attempt to solve. So we're still going to use that same strategy of, I want to write this expression in standard form. Okay, I'm just going to manipulate the left side of the equation. I'm not doing anything to it. I'm not adding, subtracting, multiplying, dividing. I'm not changing the value in any way. All I'm doing is rewriting it as an equivalent expression. So I'm going to take this expression of 6 times the quantity of 5x plus 3, and I'm going to go ahead and distribute and rewrite it as 30x, 6 times 5x, plus 6 times 3 is 18, plus 2. Now, I did not change the value of this side at all. I kept the value exactly the same. We just wrote it in a different way, an equivalent expression. 18 plus 2 is going to be 20. I can just continue to simplify, and now I have this in standard form. Okay, so now that the left side of my equation is an expression in standard form, I can go ahead and solve, subtract 20, 30x equals 30, and I would divide by the coefficient to get x isolated by itself, and x is equal to 1. All right, so now you've seen solving equations with distribution, solving equations with distribution that have subtraction within the parentheses, a negative coefficient solving with distribution. You've seen solving with distribution with a fraction, and you've seen solving with distribution when you have an additional term to add in on the same side of the equation. So you've seen this several different ways, and hopefully you're able to go back and review these notes as you practice throughout the day. You've got several different things you need to complete. All right, thank you.